Okay, welcome back everybody. Now we're going to start the last unit of quadratics where we're now going to be putting everything all together and making connections between all the different components of quadratics that you've learned so far. And you're going to learn a couple of new techniques and formulas in this unit that are going to make your lives so much easier instead of doing the long way that we've been doing thus far. Um, so this first situation, we're going to learn how to solve quadratic equations. So solving means to get the answers, right? So, and the word equation means that we're going to have an equal sign now. So we're going to have a quadratic equal to something. And we're going to try to solve for the x's that make that equation true. And what we're really trying to do is get the solutions that represent the x-intercepts of the graph. Remember, a parabola can have up to two x-intercepts because of the two arms. And when it has two different x-intercepts, like it does in this picture, we say it has two distinct, so two different real roots. And we're always interested to find out what those numbers are because they can represent real life situations like where you make zero revenue, or it could be where you've thrown something out of, say, a window of a building and you want to know for how many seconds is it in the air for until it hits the ground, right? Those types of situations make us interested in finding out what these x-intercepts are. So the solutions to a quadratic are the values of x which the graph crosses the x-axis, better known as the x-intercepts. Every quadratic equation has two solutions, right? However, those two solutions may be the same value. So remember that when you have a parabola that just touches the x-axis on the vertex, technically it's still two answers. This arm and this arm just both happen to touch at the same number. So you're going to get the same answer twice. So it's still technically two solutions, they just happen to match. So those two solutions may be the same value, or they might be what we call not real numbers. So you notice I've been saying two distinct real roots, two equal real roots, right? I've been using that word real because they actually exist on the number line, right? You can actually point to them as to where they are. However, there's a third situation where they don't exist on the number line. They're not real. So they're included in what we consider the imaginary number system, which is a different number system. Basically, no real roots is what you would say. So you would then conclude no real roots. So no x-intercepts. So no x-intercepts on the graph, no solutions to the equation. Okay, so when we're trying to solve a quadratic equation, we're looking for solutions to the equation. We're looking for the x's that make the equation true. However, if you're looking on a graph, when you're solving, what you're looking for are the x-intercepts. So they're all the same thing. So roots and zeros and solutions all mean the same thing. Okay, so I want you to get used to hearing it different ways because it all depends on what you're looking at. These are called x-intercepts, but in the case of an equation, now they're called solutions, right? Because this isn't a graph, so we don't call them x-intercepts, but they represent the x-intercept of the picture of this. So how do we do this? First things first, you always have to set the quadratic to make it equal 0. You always need 0 on one side of the equal sign. It doesn't matter if it's on the left side or the right side. That's irrelevant. But one side has to be set to 0 because everywhere on the x-axis, the height of y is 0. This is negative 4, 0, negative 3, 0, negative 2, 0, negative 1, 0. Y is always worth 0 everywhere on this line. So that's why you need to have 0 always on one side of the equation. So if you happen to have another number sitting there, you have to bring it over and join the other numbers on the other side so you get 0 on one side. So big fat 0 on one side of the equal sign. Then your goal is to factor, right? So remember our steps to factoring. I'll just review them here. Step 1, common, right? You always look for a common factor. Step 2, is it one of those special cases like a difference of squares, um, or special trinomial? Remember, this is the a squared minus b squared stuff. So only two terms, and then you square root the first guy, square root the second guy, one guy gets a plus, one guy gets a minus. Da, da, da. Is it a simple trinomial? So if it's not a difference of squares, check to see if it's a simple trinomial where the a value in the front is 1. This is where you multiply to the back and add to the middle, right? You look for those two numbers. Only one line to your solution. And if it's not any of those three, check to see if it's decomposition, which we also refer to as complex trinomial, depending on where you read it. And this is where trinomial, this is where the a value is not 1, right? So you're stuck with another number in front of the x squared. That's another number that isn't 1. So this is where you go first times last, and then you try to come up with numbers that multiply to that answer, but add to the middle, and then you have 3 lines in your solution. So this is the order we attempt. But again, remember I showed you at the end of last unit that not everything is factorable. So what you could try, if you wanted the axis of symmetry, but not if you wanted the x-intercepts, if it's not factorable, then you have to stop at this point because you can't factor. So they could be decimals, right? That the solutions to the equation. Or it could be that they just don't exist at all, no real roots. Maybe the guy opens upside down and he's been shifted down, so he's never touching the x-axis. So if they don't exist, you're never going to find them. So that partial factoring method that you learned at the end of the last unit is only good when you're just trying to find any 2 points at the same height, and you don't care what those 2 points are. And you're trying to find the middle, right, to get the axis of symmetry so you can get the vertex. If that's your goal, then you can partially factor. But our goal right now isn't to get the vertex. Our goal right now is to get these 2 numbers, these exact 2 numbers. So that means partial factoring is not really useful for us here because that's not what that gets us. So after you've attempted whichever one of these types of factoring applies to the question, then once you get your brackets, right, bracket, bracket, then you make each of those brackets, again, individually, make it equal 0, and solve for x, right, from each one. And then, of course, you can always check your answers by subbing them back into the original equation and see if it works. Left side, right side, check. So let me show you what I mean here with these examples. Very straightforward. So you notice that the question says solve. As soon as you see that direction, solve, it means find the x-intercepts. So your s and your t. That's what we're interested here. So right away, is the quadratic equal to 0? Yes. Is it in bracket bracket form? Yes. This one is already factored for you. So it would not be smart of me to expand this out. Because if I expand this out through FOIL, I'm going to get x squared, blah, 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 whatever, minus 2 at the back. And then I would just have to go ahead and put it back into bracket bracket form. So I would be undoing all the work that was already done. So that wouldn't be smart. So these are already set for me to now move all the way down to step 3. Set each factor. It's already in factored form. So I'm able to set each factor. So x plus 1 equals 0. X equals negative 1. X minus 2 equals 0. You don't really need the brackets, I guess. My bad habit here of keeping everything contained. There we go. So x minus 2 equals 0. X equals positive 2. So I know this parabola crosses one arm at negative 1 and the other arm at positive 2. That's all it asked me for. So I'm done. It's not interested in the axis of symmetry. It's not interested in the vertex. So I'm done. I finished. I answered my question. I'm not going to bother checking. But to check, you would just sub in 2 here and here. Does it equal 0? You would sub in negative 1 here and here. Work it out. Does it equal 0? That's how you could check left side, right side. Now, in this next case, again, you notice that it's already set right here to have x bracket x minus 3 bracket equals 0, which means this x and this x, right? Two locations, I can get up to two answers. This x, it's the same thing on that side. I don't know why it was repeated twice. So the x sitting by himself, you make him equal 0. Nothing to solve for. X minus 3 equals 0. Bring the 3 to the other side, you get positive 3. Right? So obviously this guy crosses at 0 and positive 3. And it's the same thing over here. I think it was just repeated twice. Now, that's just showing you examples where the work's already been done for you. But what happens when it's in standard form? And I know this is standard form because it's y squared minus 3y equals negative 2. Now it could say x squared minus 3x equals negative 2. The letters don't matter. But set it to equal 0. Step 1, we must get 0 on one side of the equation. So that means the negative 2 has to come over. Y squared minus 3y plus 2 equals 0. Now that is standard form. So now because it's in standard form, I'm able to factor. Right? I need to get it to look like this in the end, like the first one did. It doesn't look like that yet. So in order to factor it, I go through my steps. Do I see a common factor? No. Is it a difference of squares? Definitely not. It's a trinomial. There's 3 parts, so it's not number 2. Is it a simple trinomial where the a value is 1? Yeah, the a value is 1. So this is a normal parabola that opens up. So I go bracket, 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 bracket. Don't forget the rest of the equation equals 0. You carry that down. You stick a y in the front of the bracket in each case. Now we need to multiply to 2 and add to 3. Any numbers you know that multiply to 2. 2 times 1. That also gives you 3. Remember, the back sign tells you if the brackets are going to match or not. In this case, it's a plus, so we know that the brackets match. They're the same sign. And they're going to be whatever the 3 is. So the 3 is a minus. So that means that's a minus and that's a minus. Check. Negative 2 times negative 1 is positive 2. Negative 2 take away 1 is negative 3. It does work. But now we haven't answered the question. All we did was convert from standard to factored form. That's all we did so far. So we put him in his factored form, but we haven't solved yet. So again, now comes the solving part. Right? So to solve, that's where you take that bracket, you make it equal 0. Take that bracket, make it equal 0. Solve for the letter, solve for the letter. So that extra step at the end of factoring is called solving. Right? So factoring gets us to the nice package form that allows us to solve each package for the independent variable. In this case, it was called y. So it's not always going to be an x. So this parabola crosses at positive 2 and positive 1. That's all I know about him. He has 2 distinct real roots. Okay, now this fourth case looks really funny. This does not look like factored form. I got a plus 1 out here by himself. I have a minus x sitting on the other side of the equal sign by himself. This guy's a mess. So because this is a mess, we have to first clean this up. Like this does not look like anything. So the 3's got to go and multiply to everything in the bracket because I need to get everybody loose and open and free so I can start collecting like terms. So 3x squared plus 3x plus the 1, and then kick out the x to the other side so it becomes plus x equals 0, right? You always need 0 on one side of that equal sign. Put your x's with your x's, your numbers with your numbers, and so forth. So 3x squared has nobody to go with. 3x plus x is 4x. And then we have a plus 1. All right. So now I have my standard form. All of that to get standard form. But now I'm trying to get it into factored form so I can then get my x's into their packages. I go through my steps. Common factor. No, 3 does not come out of anybody. X does not come out of everybody. Difference of squares. Nope, it's a trinomial. It's not something squared minus something squared. Simple trinomial, no, because I have the 3 in the front. It can't be a simple trinomial because I'm stuck with the 3, which means I got to try decomposition, the complex trinomial method. So the complex trinomial method is where we go first times last. So again, on the side of your page, 3 times 1 is 3. All the numbers you know that multiply to 3, but add to 4. Well, 3 and 1. The signs are going to be the same. So this 3 and 1 are going to match because it was a positive 3. And they're going to be whatever the 4 sign was. So the sign of the 4 dictates. So it's going to be plus and plus. Come back in here. 3x squared was at the front. Decide who you want to go first in line. I'm going to put plus 3x. Then I'm going to put plus 1x. So here are my 4 x's sitting there in the middle still. I just decomposed that middle term, hence decomposition. And then the plus 1 and then the equal 0. This is now where we group the first two and we group the last two. Common factor the first two. Pull out a 3, pull out an x. Those are common. Leaving me behind with an x and a plus 1. Notice the second set of two terms is an x and a 1. Well, the only thing I can pull out of an x and a 1 is a 1, right? Nothing else goes into 1 and 1. And I don't want the sign to flip, so you have to put the sign in front of that 1. If you don't put a plus or a minus there, it means multiply. When I then see what's left behind, I'm going to get 1x plus 1 again. And see my brackets match. Yay, I did it right. Don't forget your equal 0 at the back. Drag out that matching bracket to the front. Leftovers go in their own bracket. Don't forget your equal 0 at the back. So now I have it in nice bracket form. It took me 3 lines to get there, but eventually I got it down into factored form. So now I'm at this point where I get to solve from each bracket. X plus 1 equals 0. X equals negative 1. 3x plus 1 equals 0. 3x equals negative 1. X equals negative 1 over 3, right? Divide both sides by 3. And there we go. So this guy crosses at negative 1 on the x-axis, and he crosses at negative 0.333333, right? Negative a third on the x-axis. So again, showing you, some already will come to you in factored form. Great. Don't waste your time expanding just to get it back into this form again. It's already waiting for you. Other ones are going to have to be cleaned up a little bit. So when they need to be cleaned up a little bit, make sure that you get a big fat 0 sitting on one side. Make sure you get it into nice standard form, and then do whatever factoring is necessary so that you can solve each of the factors for the x. If you have an x sitting by himself, not added or subtracted to anything in a bracket, he himself then is worth 0. All right, let's keep going with these other examples. So again, I see a messy one. In E, we have 2t squared equals negative 11t minus 5. So I'm going to kick things out to the left. 2t squared plus 11t plus 5 equals 0. Again, big fat 0 on one side. Not common factorable. 2 does not go into anything. T does not come out of everything. So not common factorable. It's not a difference of squares. It's not a simple trinomial because of the 2. So it must be decomposition. This is where we go first times last. So my AC product, and again, do this in your head, do this on the side of the page. First times last is 10. Two numbers you know that multiply to 10 and give you 11. Must be 10 times 1. Positive 10, same signs. They're both going to be plus. So 2t squared, I'm going to go 1t, and then I'm going to put the 10t at the back so he's closer to the 5 who's at the back, because I think 10 and 5 have more in common. It's not really a big deal. If you tried it in a different order, you'll probably end up in the same place in the end anyway. Common factor out the first two. I can pull out a t, and I can pull out a t, leaving me with 2t plus 1. Out of these two, I can pull out a plus 5, leaving me with 2t plus 1. So that means one bracket is 2t plus 1, the leftovers, t plus 5. Don't forget the equal 0 the whole way down because it's an equation. Notice I'm not putting an equal sign in the front because there's already one on each line. You're only allowed one equal sign per line. Then I'm going to solve each of these individual brackets. 2t plus 1 equals 0. 2t equals -1. Divide by 2, divide by 2. That's what we're doing here. So -1 over 2, -0.5 is one x-intercept. The other one, t plus 5 equals 0. Kick the 5 to the other side, t equals -5. Done. So again, once I get my two answers, two distinct real roots, I'm finished. I've answered the question. These are the values of t that make this equation true. So I've solved for the solutions to the equation, which in essence are the x-intercepts of this parabola. Okay, so now let's do this next one. Again, messed up. This -6 should be on the other side. 10x squared minus 16x plus 6 equals 0. Well, 10, 16, and 6 are definitely common factorable. I could pull out a common factor, but I'm going to show you what happens if you don't. If you don't common factor at the beginning, you're going to have to at the end eventually. But if you go through the rest of the factoring steps, it's not a difference of squares. It's not simple trinomial because of the 10 in the front. So again, I'm going to go first times last. My AC product is 60. Two numbers that I know that multiply to 60 and give me 16. Looks like a 10 and 6 combo, right? 10 times 6 is 60. 10 and 6 gives me 16. They're both the same sign. They're both going to be minuses. So what does that mean? 10x squared, I'm going to write -10x, and then I'm going to write -6x. So there's my -16x's. Plus 6 at the back equals 0. Common factor the first two, common factor the second set of two. Pull out a 10, pull out an x, leaving me with x minus 1. Now, I want this sign to flip to a minus, so the bracket matches. So I'm going to pull out a -6, leaving me with a positive x minus 1. That's what I wanted. Don't forget your equals 0, x minus 1 in one bracket, 10x minus 6 equals 0 in the other bracket. Now, notice there's still the 2 that's inside this bracket. So if I asked you to fully factor, technically you still have to pull out 2. It's not in fully factored form yet because you still have to drag the 2 to the front, and you would write it like this. Because 2 goes into 10 5 times and 2 goes into 6 3 times. That's a better version of its factored form. That's more reduced or simplified. And all I did was divide by 2, divide by 2. The 2 came and sit in the front. But we still have to solve, right? So let's solve. X minus 1 equals 0. X equals 1. 5x minus 3 equals 0. 5x equals 3. Divide both sides by 5. 3/5. So 0.6 and 1 are the two x-intercepts. If you didn't pull out the 2, you still would have had 6 over 10, which is 0.6. Okay, so again, when you're solving for x, it's whatever this number is in the bracket with the sign flipped. If there's two parts, flip the sign, put the back number on top of the front number. That's what the answer will always be. Positive 3 over 5, right? Which is the same as positive 6 over 10. So that's how we're solving for these x's. All right, in the next case, he's still in standard form except that the y-intercept is 0. So you notice that ax squared plus bx plus c. The c is not even listed there. So it must have been a 0. So that means we have a y-intercept of 0, which is fine. It makes things easier for us. It's already set to equal 0, so we don't have to rearrange this at all, which is great. But we have to go through our factoring steps because he's not factored. I can't pull out the 5, but I can pull out an n. So one n comes out of this guy, leaving 5n behind. An n comes out of that guy, leaving 8 behind. So now I have my two nice packages. So that's all this factoring required. So n himself equals 0. From this guy, 5n minus 8 equals 0. 5n equals positive 8. n equals 8 over 5. Right? So 1.6. So here are our two x-intercepts. It was called n instead of x, but the letters don't matter. And again, flip the sign, put the back number on top of the front number. Okay, so hopefully you're seeing that pattern. All right, next one. This looks like very, very special trinomial because pretend you didn't even, well, let's do it the quick way. Notice 25's in the front. I know the answer to the square root of 25. Notice 16 is in the back. I know the answer to the square root of 16. This is one of those perfect trinomials. So this is a very special case that if you happen to see it, good for you, because then it saves you some time, because you can go right into factored form. So if you do the trick, I'll call it the trick. It's not really a trick. Square root of 25, then an x, and then the square root of 16 in the back. Signs are the same. They're both plus. Let's just check. If you put a square on that, what if you expand this out the quick way? Do you get this back again? 5x times 5x is 25x squared. 5x times 4 is 20x's, double it, 40x's. 4 times 4 is 16. So right away, we got it straight into factored form, right away, because we saw the pattern of a perfect trinomial because the numbers are great. But if you didn't see it, it still doesn't matter. You still would have factored using decomposition because nothing else goes into all of these parts nicely. So unfortunately, you're going to be stuck with, because 5 doesn't go into 16, so you're stuck with these high numbers. So you're going to have to do it the long way. So decomposition would be considered the long way in this case. So 25x squared plus 40x plus 16 equals 0. AC is whatever 25 times 16 is. And that's 400. So that's nice. Something that multiplies to 400 and gives you 40. 20 times 20, right, is 400. And 20 plus 20 is 40. So maybe that works. And they're both the same. They're both pluses. So 25x squared plus 20x's plus another 20x's. There's my 40x's plus 16 equals 0. Common factor the first two, common factor the last two. 5x, leaving me with 5x plus 4. Pull out a 4 from the last two guys. Leaves you with 5x and then again a positive 4. So that means one bracket is 5x plus 4. The other bracket is a 5x plus 4. Look at that. It's the same final conclusion. Factored form looks the same. I just put a square on this bracket instead of writing the bracket out twice. But basically, when we solve for x equals negative 4 over 5. You're going to get the same answer twice. X equals negative 4 over 5. X equals negative 4 over 5. X equals negative 4 over 5. So it won't matter. Right? You set it to equal 0 and you rearrange and you solve for x. So this is where we would say two equal real roots. Two answers that worked out to be the same answer. Okay, so the solutions here are the same. So they're two equal. So I just wanted to review again that if you happen to notice those perfect squares, whether it's a difference of squares or a trinomial, like it was in this case, you can go straight down to that step, omitting all of these steps that are required for decomposition. But eventually you get to the same place in the end. So it won't matter if you see it or don't see it right at the start. Now, this guy looks ugly. So because he looks ugly, and fractions, and everybody hates fractions, I would advise you to get the lowest common denominator. And that way, because it's an equation, then you don't have to deal with the denominators. So the LCD between 8, 4, and 1, because remember we have three fractions we're dealing with, is 8. Everything can come up to the level of an 8. 8 is the lowest common denominator. It is not 16. It is not 32. Those aren't the lowest. Those are common denominators, but they're not the lowest. So why would I go higher than I need to? This guy can become an 8. This guy can become an 8. That guy can become an 8. So 8 plus something over 8 equals something over 8. So all I did was make all the bottoms an 8. Now on the top, this guy already came with an 8. So that means because he already had an 8, he's not changing. The second guy came with a 4. So in order to bump him up to an 8, I have to times by 2, times by 2, top and bottom, right? Proportional. Gives me 5x times 2 is 10x. The last fraction came with a 1, so I had to times that by 8. That means I have to times the negative 2 by 8 to give me negative 16. Because now they all have 8s at the bottom, we drop the denominators, which means the denominators don't work. They don't matter anymore. It's not that they don't work. Everything's proportional. So technically, it's just x squared plus 10x equals negative 16. That's technically your equation now. The 8s on the bottom are irrelevant because they all match across the board. So that's a much easier thing to deal with than up here. So I always suggest when you have multiple fractions in an equation, you get a common denominator. So x squared plus 10x plus 16 equals 0. You still have to make it equal 0 on one side, clean it up, and do what you would normally do. So now we go through our factoring steps. So in our factoring steps, we have to figure out, do we have a common factor? No. Is this a difference of squares? No, it's a trinomial. Is it a simple trinomial where the a value is 1? Yes, it is. Bracket, 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 bracket equals 0. Stick the letter in the front of each bracket. What two numbers do you know multiply to 16 and give you 10? Well, 1 times 16? No. 2 times 8? And 4 times 4, right? Those are basically your options. Looks like it's got to be a 2-8 combo, right? So again, if you're the type of person that needs to see it, then you just jot it down on the side of the page, stick one number in one bracket, the other number at the back of the other bracket. The signs are going to match, so your brackets will match and they will both be pluses. So all of that, simple trinomial, go straight to your answer. Notice I'm not doing decomposition because it's not necessary. Why would I do decomposition here and take 3 lines of work when I just go straight to my final answer? So it's important that you're not wasting time doing things unnecessarily. All right, solve, because remember, that was the whole point. We have to solve for x. X plus 2 equals 0. X equals negative 2. X plus 8 equals 0. X equals negative 8. Now I've solved for my x-intercepts. This guy has two different real roots. And we've solved. So we're done. Those were my two x-intercepts. So that's the purpose of factoring, is to get you from standard form to factored form. And then once it's in factored form, we can solve for the x's that make the equation true, called the solutions, which in essence are the x-intercepts of the parabola. So definitely do your practice because it's also good practice of your factoring skills. But I'm sure you're asking the question now, what if something cannot be factored? What if the numbers just don't work? And I'm going to show you what to do in that special case as well in another lesson. All right, so get to practicing and